Okay, good afternoon, everybody. My name's Matt Goodridge. I'm a product manager on the managed Google Play Store. That's Google's enterprise app management and platform and app marketplace. So hopefully it's not too much longer before you guys get some beers, but for now you're stuck with me. So quick show of hands, how many developers have we got in the room? Awesome. Well, we're going to have some code samples for you, so hopefully that will keep you entertained. So whether you're an ISV, so an independent software vendor, or an enterprise developer, or a development agency, this presentation aims to give you some tools and techniques to make the best out of your Android development in the enterprise. First of all, though, why are we investing in mobile? Well, mobile is now becoming a significant part of most enterprises' digital strategies. And let's actually look at some data as to, well, why is mobile so important? Well, first of all, it's about increasing software revenue, or sales and revenue. It's about improving employee productivity and then decreasing costs. Right? And there's many other reasons for it as well, but those are really some of the top ones. Then in terms of Android, Android is is the biggest operating system in mobile across smartphone devices today, and that extends into enterprise. 68% of mobile devices shipped through an enterprise channel were Android last year. And Android has a huge range of devices that it works on. So everything from a smartwatch to smartphones, tablets, and then recently, last year, we've announced Android apps running on Chrome OS. So you've now got Android apps running on laptop devices and on large screen devices. So Chrome OS version 53 and beyond on selected models, and then all Chrome OS devices launched from this year onwards will be able to support Android apps. So if you're thinking about developing on Android, this is a really good time. So let's also have a look at the nature of mobile apps. Well, although hybrid type apps and web type apps on mobile are inherently cross-platform, actually what we see in enterprises is they continue to develop on the native platform itself, even though most enterprises are cross-platform in their nature. So they have employees that are using iOS as well as Android devices. So we're really going to focus here on native Android app development. And then in terms of how do those Android apps actually interact with other services, well, when we surveyed developers, we found that the vast majority, well over 90% of Android apps, are actually part of a bigger software solution. So they are communicating with a cloud backend. So we're going to assume, for the purpose of this presentation, that that's going to be the architecture. So let's just structure this session briefly. So we're going to talk in 3 sections. First of all, we're going to focus on some aspects of design. Then we're going to talk about building Android apps. And then finally, deploying those apps out to enterprises. We're going to talk about some critical best practices, and there's a lot of these have got much more detailed documentation available on the web. I'm going to show a bunch of QR codes in the corners of the slides. You can then use those to look up that documentation. Some of them are things like video links, which you can go and have a look at when you're back in the office. So first of all, let's talk about design. Why does it matter that you spend time on design? From an enterprise perspective, it's about cost of your operations. Huh? What do you mean cost? Well, we've seen that mobile is about increasing productivity. So, and if that's the main reason that you're rolling out your apps and services to mobile, then there's a few things that we need to think about. Those apps need to be quick for the employees to use, which means the lower time cost. They've got to be easy to use as well, so that you don't need to have support or lower support. And then minimal training required, again, lower time cost. So if you don't carefully invest in design when you're building your app, you can actually risk missing out on some of the key benefits that you set out to when you originally decided to go mobile. So how can mobile really benefit your users? We're going to focus, first of all, on how you can use all of the sensors and peripherals that are built into modern mobile devices. Because those are really going to help you, your users, quickly get information into apps rather than having to type everything manually. So mobile devices have a wealth of sensors and peripherals. You've got cellular connectivity as well as Wi-Fi. You've got GPS location. You've got motion sensors like gyro and accelerometer. You've got proximity, NFC for swiping badges, Bluetooth for local connectivity, but also potentially indoor location using Bluetooth beacons. Cameras for QR codes, augmented reality. Microphones for things like voice recognition. A flashlight or torch, depending on which side of the pond you're from, for providing light, and then fingerprints, which sort of make your security workflows, your sign-in workflow, much slicker. So let's just look at a few examples to illustrate some opportunities here. Sometimes it's some really, really simple things that help. In this example, British Gas have added just a light function to their meter reading app. What they realized was gas meters are often in dark places, and having that light quickly to hand when they're entering in the meter reading actually made it much quicker to read a meter. So let's just look quickly at the code here. So the light on a smartphone is actually part of the camera module. And there are multiple camera modules on many smart devices. So you need to then iterate through those and identify, well, which is the camera module that the light is associated with, and then switch that on. And then returning the state back to the calling method so that it knows that I've found a light to switch on. You could also be a little bit more ambitious with something like augmented reality. So here's an example from the marine industry, helping mariners add important information about local shipping. So to get started with augmented reality, one of the things that you need is a fixed reference point in order to match the image overlay with the image that you're getting from the camera. There's a really, really good reference point, which is gravity. Gravity is always pointing down. And conveniently, Android provides a sensor for the gravity vector. So you can look at, or you can get the gravity sensor from the sensor service within Android, create a callback method, which then, for each update of that gravity vector that the sensor is taking, you can extract that vector and then use that to update your overlay over the image that your camera is taking. And then, of course, we need to enable that callback method by registering it as a listener for updates from the gravity sensor. And then finally, I want to give you an example of an internal app from Google called Google Fixit. Fixit is used by Googlers in order to report problems with our buildings facilities and our IT equipment that's around our buildings. As you can see from this screenshot, before I've even entered a location, it already knows that I'm on the 10th floor of the building that I was in when I took this screenshot. And when I then start to enter the exact room, it will auto-complete for me. So there's three things that we really need to do to get that kind of experience. Number one is get the location. Secondly is to look that up against a series of points of interest that might be interesting in your application. and then of course do the autocomplete. I'm going to focus here specifically on the location piece because that's the mobile bit. The rest you'll probably already be doing in the cloud. So on the location side, there's really two techniques for this. Android already keeps a regular poll of your location. So you can just look up the last known location of the device. But that's sometimes not entirely accurate because it only does that at a relatively low frequency in order to conserve battery life. But it might be useful if you know your user has been stationary for a while. It's also very quick because that location is already stored in memory. The second approach is then to start listening for location updates. So this is then activating the particular location provider. In this example, I've got GPS. Right? And as you probably know, it takes a little while for a GPS chipset to actually acquire a good fix of satellites. So you can start sampling location updates and then provide those location updates to a short method which can then determine for you which is the most accurate take. So for this particular example, one way to get a combination of accuracy and a good user experience is as soon as the user first clicks into the auto-completing text field, is to first call the getLastKnown location method, so you can get something quickly, responsively for the user to start typing. But at the same time, start sampling with for a new, more accurate location. And as your user is typing, you're anyway updating your autocomplete list. You can also be using an updated location in parallel in order to refine that list, and therefore minimizing the amount of time that your user needs to spend when entering this information. So we're going to change gears now and talk about some techniques for building your app. The first one, of course, is security. So I could probably spend most of today talking about security on Android, and there has already been a number of talks about that this week. But let's just structure this, and then we can focus down on a particular area. So I've got three areas here. First of all, platform security. We harden the Android platform against direct attack. Ecosystem security. We're providing security updates for device OEMs. We're also putting in a lot of app scanning and other tools within Google Play to make sure our users are confident that apps that they're installing are safe. And then finally, the apps themselves. Your apps need to be themselves free from vulnerabilities. So Adrian Ludwig, our security director for Android, spoke yesterday, and he really focused on numbers 1 and 2. So I'm going to focus here on some techniques that you should think about in number 3, really making sure that your apps are free from vulnerabilities. So the top 3 things, if there's just 3 things you think about when securing your app, these are the 3 that we recommend. Firstly, making sure you're using only secure network protocols. Secondly, using the default local storage that's provided by Android. And then thirdly, checking that the device is authentic and uncompromised when you're running on it. There's a full list, actually, at this QR code here with extensive details about how to further secure your apps. Let's just go into a few more details, though. It might be stating the obvious, but we see this time and time again, that apps are still communicating to their backends in clear text. So let's just reiterate this. Securing and encrypting your app's communications to its backend is absolutely critical in protecting data in transit. The most effective way of doing this is to tell Android to stop your app from actually using clear text protocols. And you can do that in your app's manifest. You can simply set up a network security configuration to ensure that clear text traffic is not permitted. This is particularly important when you're using third-party SDKs. Like, you can set up development processes internally to make sure that you are yourselves writing SSL-based communications. But if you're using third-party SDKs that might also be communicating to some backend, enforcing this here will mean that those SDKs also can't use clear text protocols. If you're using Firebase for your app, then that already uses secure protocols back to Google's backend. While we're on the subject of secure protocols, you should also be aware that many enterprises use content proxying as another measure to secure their data. The way that works is that the enterprise would deploy a SSL certificate, a custom certificate, on the device, and use that for the SSL encryption to the proxy, and then the proxy back to the service backend would then use the service's own certificate. So in that case, you effectively man-in-the-middling your own app. Since Android Nougat, we've made some security changes such that Android actually ignores those custom certificates unless an app explicitly opts in. So here you have in the manifest then a way to actually opt in for that. If you're a development agency or you're an internal enterprise developer, then actually finding the list of domains that you need to whitelist is probably straightforward, and that list is relatively small. So you can set up a whitelist a lot like this. If you're an ISV and potentially using or distributing your app to many customers, then that list of domains is going to be very, very long. So you should consider enabling that for all domains, and you can set that as a base configuration within your network security policy. Obviously, that opens things up a little bit. So the way the enterprise can then re-secure that to make sure that we haven't introduced any additional security holes there is to use device management, where they can restrict and manage which certificates are actually deployed to the device. So let's move on now to data storage on the device. So Android uses a sandboxed execution environment such that all of an app's data is only available to that app itself unless it's explicitly shared. Also, from Marshmallow onwards, we've required the device storage encryption to be implemented as standard. And if the device is managed by an enterprise mobility manager or a device management system, then that actually might be required by policy. Also, in Android Nougat and beyond, we can also use separate encryption keys for work data versus personal data in storage, and we're going to talk about data separation in a little bit. On external storage then, external storage is globally readable and writable. It's not part of that sandboxed execution environment. So you really shouldn't store any sensitive information in that area. Also, an administrator might set policies to actually block the use of external storage. So you should certainly have a fallback position if you do need to use that. Also, if you do need to use it, do make sure you perform input validation when reading back from that external storage, as you would for any other untrusted source of data. And then finally, how do you know that the device that your app is running on is not vulnerable or compromised? Well, the Safety Net Attest API, which is part of Google's mobile services, provides you that capability. It examines the software and hardware information about the device that you're running on, and it attempts to match that software and hardware fingerprint against a set of known fingerprints that Google maintains. It does basic device integrity checking, and it also can check details about the APK, your app, that's calling that API as well. And then you can send that bundle of data back to your server to interpret to make sure not only is the device uncompromised, but the app that's calling your server is itself the app that you expect it to be. You might have caught Ed Cunningham's talk earlier this afternoon, which was at Google Security Services for Android. If you didn't get a chance to see that, then do catch the video. He goes into a lot more detail about how this works and how you can implement it. Also, there's more details at this QR code. So let's move on then to single sign-on. Many companies use single sign-on to enable their users to use a single username and password for many software services. It's been a feature of web-based services for a long time, but getting a slick experience within a native mobile app has been pretty challenging until now. So here we're assuming that there's an enterprise authentication server in the back end, and you're potentially using a third-party identity provider. So today, a user first of all needs to enter an identifier when they log into this app. Particularly if this is an ISV's app, the app itself doesn't necessarily know yet which identity provider it's going to go back to. So when they enter their username, the app and the service backend is then going to use that to determine which identity provider to make the authorization call back to. Then once that's done, the identity provider will present the login screen. The user needs to enter their username and password, and they're in. But then they have to do the same for each individual app that uses those credentials. Wouldn't it be great if mobile SSO could actually work the same as it does on the web? Well, the good news is it can. So, and once you've got an established login session, for each app that the user starts using, they can go straight in. So there's two steps to that. First of all, we've got to determine which SSO provider to use. And then we're going to use a feature of Chrome custom tabs, in order to persist that login state. And so that all apps which are using the same technique can share that login state. So here's quickly how that identity provider resolution works. So we're going to start off with an enterprise mobility manager. So the device is under management. That's going to send a login hint field down to the Android app. Now, this should start to sound familiar if you've implemented SSO on the web. We're going to talk about exactly how you get that configuration down to the mobile app a little bit later. So the Android app's now got this login hint. This is probably the user's username. The app can then send that down to the SaaS backend and then onwards to the auth server and determine which is the identity provider to use. The identity provider will then present the login screen up to the user. Now, if you've configured the auth server to pass that login hint directly into the username field, then that username field can already be pre-populated for the user, and all they have to do is enter their password. So then let's talk about how do we persist that login session. So we're going to use Chrome custom tabs. But let's first talk about what exactly is a Chrome custom tab. It's a secure context so that it can load any web page, but that host app can't actually inspect its contents. Users can see the server address, but they can't edit it. And the cookie state is shared between any instance of a Chrome custom tab and indeed Chrome itself. So that's how we're going to get our persistent login state. It's a system browser activity, so you don't need to worry about a user having to navigate to another activity and then come back again. It's been built in to Chrome since version 45, so it's been around a little while and is almost guaranteed to be on a Chrome version that you're running on. And it also works from Android Jelly Bean and beyond. In this example, I show Google accounts, but you don't actually need to be using Google accounts for this. This will work with any supported identity provider, whether they're using OAuth or OpenID Connect. So the good news is the OpenID Foundation have put together a library called the AppAuth library, which encapsulates all of these elements and does a lot of the heavy lifting for you, so that you can quickly pull together your authorization step. That library is available for Android and iOS, and as I said, it supports OAuth 2 and OpenID Connect. The Chrome Custom tab then is built into that, and it uses the shared Chrome cookie jar. But it'll also fall back to a default browser if Chrome just happens to not be available. So what that means is we can completely simplify the SSO offering, making sure that users don't have to be continually logging in using their username and password. And you can also implement more consistent session expiry policies without causing a really big UX headache. Don't forget, though, we need to enable the app to accept that login hint configuration. We're going to talk about that in just a bit. So head on over to github.com/openid. There's also a video here which goes into a lot more detail over the course of half an hour, where it'll give you the details of how to implement that and some of the gory details of how it really works in the back end. So let's move on now to talk about Chrome OS. So you've probably heard already that Chrome OS now has started supporting Android apps through Google Play. What's actually happening in the background is Chrome OS includes now a fully CTS-compatible instance of Android running, and it's actually Android Marshmallow that's running currently within Chrome. And for the most part, apps just work. But of course, there's a set of optimizations that you can make to make the best use out of a Chrome device. And we'll go through each of these. So first of all, we've got to ensure that it's compatible. For the most part, it will be, but there's a few things that you've got to bear in mind. First of all, Chromebooks don't necessarily have a touchscreen. So the best way around this is to make sure you explicitly state in your manifest that you don't need a touchscreen. But of course, with a trackpad and or a mouse, the Chrome device will actually implement what we call fake touch. So you still have that similar kind of interaction. And you should handle then those differences at runtime. The other thing worth pointing out here is that things like GPS, accelerometer, and gyro are often also not included. So don't require those in your manifest as a static requirement. Rather, handle their absence, if they are absent, at runtime. Of course, on a Chrome device, whether you've got a laptop or a large screen display, you've got a lot more screen real estate to play with. Have a look at how do you reflow your app, for example, from what's probably a single column layout on a smartphone to a multiple column layout on a much larger device. What this means is that your users are able to use a lot more of your app's functionality without having to scroll backwards and forwards. Also, things like opening menu items and menus by default. This means that your features are much more discoverable. Also, you need far fewer clicks for the user to access that functionality. Chrome OS has multi-window support. The Android apps in Chrome OS lay out into various different sizes at the moment, and very soon they'll be able to do full variable window scalability. But for now, there are three layouts. There's portrait and landscape, and they're very much the aspect ratio of a Nexus 7 or a Nexus 9 device. And then, of course, full window mode as well. What you need to do is make sure that you test your app in these various modes, and particularly the transitions, to make sure that your app is reflowing and looking nice as it does so. So let's talk a little bit about keyboards and text entry. Well, text entry and things like point and click with the mouse will just work. But when your users have got a physical keyboard in front of them, they will expect keyboard shortcuts to work. You should add keyboard listeners to either your activities or your views in order to provide that kind of functionality for your users. In this example, I've taken one of my activities and I've actually overridden the on key up method, looking for a control P. And then I call my print method. Bear in mind, though, that if there's explicit key combinations that you're not handling, make sure that then you're passing that on key up method back up to the superclass in case that's handling it. Chromebooks have started coming with styluses. For example, the new Chromebook Plus and Chromebook Pro from Samsung. Those styluses are not actually Bluetooth, yet they use a different technology, but they behave in Android the same way as a Bluetooth stylus, and they're accessible through using the same methods. So the way you handle these is through handling motion events. You can use motion events and their constants to actually filter for the different actions. In this example, I'm explicitly filtering for a stylus and an eraser events. What that means is I can be doing particular actions with a stylus at the same time as having different actions for finger touches. So you might, for example, allow the user to be drawing with the stylus, but then panning and zooming with the fingers, which actually gives a very tactile kind of user experience. The styluses are double-ended, so you have a drawing end and you have an erasing end. The other cool thing, and you'll see this in my draw method at the bottom here, is there's two other parameters that come from a stylus. The pressure that the user is applying to the screen, and also the tilt of that stylus. So you can get really, really creative with what you can do with things like drawing and other input techniques with that stylus that you can't actually do with finger-based touch. So let's now talk about developing on managed Android. So over the last few years, Google's introduced a comprehensive suite of device and app management features into both Android and Google Play. We're working together with 21 enterprise mobility management partners, including companies like AirWatch, MobileIron, BlackBerry, SOTI, and of course Google Mobile Management, which comes as part of G Suite. There are two management modes that I want to discuss here today. First of all, the work profile, which is predominantly used in a bring your own device or BYOD model. Here, work data and personal data are kept separate in two separate Android profiles. And apps and notifications that are running in the work profile are then labeled with the orange briefcase badge. The fully managed mode is typically for devices which are owned by the enterprise. And they give administrators full visibility of what's going on in the device, including some deep inspection techniques like process logging, remote bug reports, and forensics. Across both of these management modes, managed Google Play is used to distribute apps. We're particularly proud of the work profile. In the work profile, IT administrators can be confident that the data is secure. They can set policies to ensure things like copy-paste doesn't work from within a work app into a personal app. So it really is like having two separate devices. At the same time, the IT administrator can be confident that they're not coming into contact with the user's personal data. This can be important for compliance reasons, particularly in regions like the EU. On the user's side, they can be confident that their employer isn't spying on their personal usage of their own device. And if the user leaves the company, the IT admin just removes the work profile and the rest of the device is left intact. So from a development standpoint then, the fully managed device mode doesn't actually present any additional hurdles. The apps just work exactly the same way. But in the work profile, there are a couple of things that you should be aware of to make sure that your app supports. So first of all, handling intents, and then secondly, sharing data with other apps. So similar to the copy-paste example, an IT administrator can block different kinds of intents. And it's very difficult for you as a developer to know up front which intents are allowed and which are blocked, and which might be resolvable within the work profile. The best way to check that is to call resolve activity for your intent before you try and fire it. And that means that if it doesn't resolve, and this method returns null in that case, then you can handle that gracefully rather than that intent going into nowhere. On the sharing data side, don't use file URIs for sharing data when you hand off to another app, because file URIs are not going to resolve in the other profile. Instead, rather use content URIs and grant explicit permission to the destination app to access that data. You can find a lot more detail at this QR code if you're interested. So I briefly mentioned managed configuration before. Have you ever had the experience of having to configure a complex application as a user? Something like a VPN client, or even something as simple as a mail client. Sometimes there's a series of complex parameters that a user might have to enter, and this can lead to expensive support calls if not done properly. Managed configuration allows you to set those remotely and automatically. And it's supported for both the fully managed device and indeed the work profile. One thing to bear in mind though is don't send credentials using managed configuration. So how does that work? Well, first of all, we're going to set up the schema for that configuration within the app's manifest. So when you publish it to Google Play, that's then going to read the manifest and then make it available to the Enterprise Mobility Management Server, which can then present a user interface to an IT admin, who can then send that configuration down to the device. So let's just see an example of that in code. And we're going to go back to the SSO example that we talked about before and see how do we add that login hint field into the configuration. So as part of the manifest, we can add a restrictions.xml file. Actually, the Android APIs talk about app restrictions, but we talk more fully about this feature in managed configuration because it isn't just about restricting the behavior of your app. Here you can see a number of parameters that we need to provide for each data field. And of course, the login hint here is going to be a string. Then, of course, you need to get the values within your app at runtime. This is straightforward to do. You just need to call the restriction service, and then using the key login hint out of the key value pair, you can get the value for that. Also bear in mind that the IT administrator might send new values to that field while your app is running. So you should also make sure you can handle updates. The way to do that is to set up a broadcast receiver which will handle the broadcast intent sent by the system when new app configuration comes down to the device. And then, of course, register that receiver to receive that broadcast. The thing to bear in mind here is you can't do that statically in the manifest. You have to do that dynamically by registering the receiver at runtime. You should also be aware of an industry organization called the App Config community. App Config was set up by some leading enterprise mobility management partners, and they're working with developers, mobile platforms, and others in the ecosystem to build out common best practices to enable apps and mobile management to work well together. Google is working with App Config to lay out the Android guidance. There's also a special case of fully managed devices, which is for single-use devices. Things like kiosks, ruggedized devices with barcode scanners, EPOS terminals, and interfaces to large equipment, all examples of single-use devices. And in those cases, you don't want the user to be able to go back to Android, the launcher, to settings, and do other things with it. You want to just work with the single app in front of you. As of Android Marshmallow, we've introduced a new capability called Lock Task Mode. In Lock Task Mode, the user can't actually escape the app that is locked to the screen. You can also stop the device from switching off the screen, so you've always got an attractive display switched on. Things like the Home and Recents button and settings are all hidden, so the user can't tamper with the device. It really is locked down. So how do you actually enable that? Well, first of all, the actual devices themselves need to be under management, so through an EMM or Enterprise Mobility Manager. That EMM needs to whitelist your app with the system to make sure that that app is authorized. Then once that's done, it's actually very straightforward to lock your app to the screen. It's worth, though, checking that your app is actually whitelisted. So checking this, is lock task permitted? We'll actually check that the EMM has been through that whitelisting process. And then you can invoke the lock task mode. The thing to bear in mind is when you're testing, make sure it's easy to unlock the app again, because it's we've seen it time and time again, developers locking the app to the screen and then not being able to unlock it without rebooting and loading the app back onto the device. So as an example here, a company called Team, formerly Eventboard, are using this on Android devices. Team have a meeting room management app together with tablets or kiosk devices to manage meeting room bookings and other things around the meeting room. It's solely for meeting room management, so they've locked their app to the device to avoid users from tampering with anything else. Team actually use a combination of the single-use APIs, like Lock Task Mode, together with the Android device management APIs, so they don't need to use a third-party EMM. They have the solution end-to-end together. And Team provides all of that functionality within their own management portal. So let's move on then to deploying your apps into enterprises. One of the big challenges here, if you're using a home-built enterprise app store or going through an EMM potentially, is you have to enable unknown sources in order to allow those apps to be deployed. Unknown sources allows users to download and install apps from any source, not just potentially the enterprise app store that you want them to. This can be a major security risk. It's difficult to push apps to devices without user interaction. Very often we've seen that users have to accept that push install, which can be frustrating for admins who are trying to get apps to users very quickly. Also, there may be other apps, for example, the Consumer Play Store, which is allowing the user to install apps in an uncontrolled way. So we've introduced management capabilities within Google Play to provide an enterprise app store for users. IT administrators are able to curate that app store for their users, laying out those apps into clusters and pages to enable easy discoverability. The IT admin is also able to whitelist explicitly which apps are allowed within the workspace and which are not, ensuring the security of any data in the work profile or fully managed device. But the question is, well, why really work with Google Play? Well, and this slide has probably been seen at least, this is the fourth time, I think, during this conference. But this is really the critical part of it. Google Play is a secure source of applications. We've been collecting data about potentially harmful applications for the last 2 years or so. And the data is really quite remarkable. If you split that data on potentially harmful application infection rate by those devices that are solely getting apps from Google Play versus those that are getting them from other sources, you see a factor 20 difference in the infection rate from potentially harmful applications or malware. And those results are very consistent, as you can see. So unknown sources really indiscriminately opens up devices, and we really recommend using Google Play as your enterprise app store, as well as, obviously it's a great consumer store as well. So why else? Well, Google Play as a platform has a number of big benefits. Firstly, it's secure. We're using strong authentication with encrypted delivery of those apps down to your device. And those apps are all signed, and we're making sure that any updates of apps are signed by the same key as the original app itself. We have a global server footprint. Urs talked a lot about that this morning. We use patch updates. Rather than sending the whole APK down for every update, we only send down the differences in a compressed format that significantly reduces bandwidth requirement and also battery. We do APK scanning to making sure that those APKs, your apps, are free from vulnerabilities. I'll talk a little bit more about that in the next slide. We provide comprehensive publishing tools. I'm also going to talk more about that in a minute. Reporting tools, things like seeing how quickly is the app being installed out to users, crash reports, and so forth. And updates are deployed automatically in a sensitive way to both battery and bandwidth. On the management side, we enable IT admins to curate that store, as you saw in the screenshot. Push installs and managed configuration we've already talked about. And there's actually no need to use Google accounts. We've got the ability to work with any identity provider with Google Play without having to create separate Google accounts. And of course, we've got a full set of APIs which your favorite EMM can integrate into. So let's just quickly look at that APK scanning. If you went to Ed's talk earlier today, he will have talked a lot more about this in detail. The thing for you to consider, though, is you don't necessarily know what SDKs and what versions of those that your dev teams are using. This isn't about scanning for malicious intent necessarily, but it gives you an early heads up to legacy versions of SDKs that might have vulnerabilities. You remember all the PR around the Heartbleed vulnerability a couple of years ago, where legacy versions of SSL were being used across the internet, causing complete chaos. We are able to detect all of these vulnerabilities on this slide today, and we're adding to that list all the time. Also about rollout management. Google Play now provides a comprehensive suite of rollout tools. Things like alpha beta testing. You can create groups of users for early versions of your app, which will then roll out automatically to those users using the same update mechanisms that Google Play uses for regular updates. But that then protects the rest of your user base on the stable production version. Once your alpha or beta version is ready for prime time, you can then use controlled percentage rollouts in order to slowly ramp up the number of users that you have on that version, and you can halt that at any time if you have problems. You can also you can publish at a particular date. We've also just launched a fully managed app releases process where you can really define a release at the beginning of that flow and then take it down through alpha, beta, and production. And you can watch a great video by a colleague of mine at this QR code. So if you are an ISV or an agency developer, you can just start straight away by registering for a Google Play developer account at this URL. All you have to do is pay a $25 sign-up fee, which is a one-time fee. If you're an IT department, you need to be working with an EMM that we've partnered with. Here is a selection of the 21 EMM partners that we're currently integrated to. I particularly want to highlight, since we're here at Google Cloud, how you set this up with G Suite. So if you're not already using Google Mobile Management, you'll see this little pop-up, Set Up Mobile Management, in the front panel of the administration console. You can, once you've signed up to that, then within the administrator's role-based access setup, you can then create an administrator with the ability to upload private apps to Play. If you want to publish public apps, then there's nothing else you need to do for your administrator. Then for that admin, sign up to the same Google Play account that we saw in the previous slide. And then if you want to set up private applications, which are restricted to your business, then you'll see this restrict distribution section, which you can just check. And actually, this is an example of my company. For agencies, you can get delegated access to your customer's developer account so that you can manage the publishing and update flows on their behalf rather than having to send them APKs for them to upload. Google Play's role-based access mechanism allows your customer to then delegate access just for your apps rather than them having to be concerned potentially with you interfering with apps that they're publishing directly. So that was a lot of content we've been through, but let me just try and summarize that. I think what we've shown is that Google has a comprehensive set of products, features, and tools to really help you get started with publishing Android apps in the enterprise. Remember to carefully consider your design to make sure that you really do get the best out of your mobile deployments. Don't just port your apps from desktop. When you're building, build with security in mind first. Get consistency across your fleet by not only supporting Android, but also optimizing for Chrome OS. And enable management to have your app deployable in the largest number of situations. And then finally, deploy using Google Play for secure, reliable, and manageable deployment. I also want to highlight that if you want to sign up for more information, please go to this link where you can sign up for a newsletter and further information about everything we're doing in connected workspaces and mobile.